Thank you very much, and thank you all for coming, and thank you, Sophia, for inviting me. Um, yeah, so this is a part from a talk on that I call Bridging Vision and Language with Data from Perception to Understanding. Okay, so why vision and language? One of the premises of artificial intelligence is having agents that we can communicate with in natural language, and they can perceive the environment and take actions in the physical space. And we can achieve that with multimodal understanding and multimodal agents. And actually, when I started my PhD a few years ago, like in 2019, it was more difficult to justify. But now, when we have a very nice example from GPT-4, for example, it's easier to justify why vision and language is cool and like important. For example, in this instance from GPT-4, you can take a photo, an image from your fridge, and GPT-4 comes up with food recipes. And here you can like sketch a website, and GPT will come up with the code to generate this website. So this is becoming really helpful and efficient. Now, I want to emphasize that we now need reasoning beyond recognition. So far in like computer vision, we are familiar with ImageNet and MS-COCO, which are datasets for recognition, identify things in images, but these are not the main bottleneck right now. And we need reasoning, we need understanding, and to emphasize, like to demonstrate, let's think about what make these images weird. Like take a second and, for example, take a look on this image, for example, and tell me what makes this image weird. Can you guess?
Looks like Bill Gates.
Yeah, this is correct. And why is it weird?
Well, it's kind of uncanny valley. Like I can see it's kind of him, but it's definitely not him. Yeah.
He's on a Mac.
Yeah, correct. Yeah, he's on a MacBook. So Bill Gates is the founder of Microsoft. Is unlikely to be seen with a MacBook. Cool. So we will see, and like the other images also have this kind of tricks. You can think for yourself, like, and we will see more examples from this in the next slides. But basically, we understand that AI needs to be grounded in the real world to achieve true common sense reasoning. In all of these images, this is a woman with a carrot on her eyes instead of cucumbers. And this is weird because usually it is cucumbers because cucumbers have some kind of a moisture element that help to reduce sourness in the eyes. So again, there is some real world reason grounded on some fact that we now require and expect our agents to understand. Cool. So now let me introduce Visit Bench. So this is not about the weird images. We will get to the weird images later. Visit Bench is a benchmark for vision and language instruction following inspired by real world use. And this is again motivated by the fact that we now have agents that are capable of performing instructions and answering questions with with long outputs and open-ended questions that are not like VQA. These are not short VQA questions. Like, teach me about this painting. So this is a painting, a famous painting by some artist. I'm not sure, actually, I don't remember which one. Or here is a photo of my bathroom. How can I design it nicer? And think about, okay, you have a model response. How do you evaluate whether a model response is correct in this case or not? So these are challenging instances. Or for example, tell me what is notable or important about the event in this photo. So any of you recognize this photo and can answer the question? Okay, so if you will use this is small. Yeah, sorry for making it challenging, but this is Lance Armstrong, the famous bicyclist, and he is now winning the some Tour de France, I think, and later he was claimed to use drugs. So this is like the event in this image that is notable, and we will be very appreciative if our models will be able to conduct such reasoning examples. So for that we built VisitBench. So again, we have some instance and we have a response, and we need to now evaluate all of the parts of the response, and to say whether this is, like, first of all, is it correct, is it engaging, is it interesting, maybe it is harmful and biased. So we don't want that. We want to really have a good sense of whether a model response is correct or not. So yeah, the motivation is that the evaluation for real-world human chatbot instructions beyond VQA is often limited, and it is challenging to quantify, and VisitBench comes to address that. So how does a VisitBench instance look like? So we have an image, we have an instruction, create a catchy title for a country song based upon the device printed on the wheelchair. And we now have instruction condition caption. And instruction condition caption is a caption that is detailed enough for an LLM to follow the instruction. So again, we have an instruction, we have an image, and instruction condition caption is some way of a bridge between the visual information to the textual information. And the instruction condition caption describes the image in words. There is a Jeep parked on the street, blah, blah, blah. But importantly, the instruction condition caption should indicate the parts that are required to follow the instruction. It is not following the instruction. The instruction condition caption does not creating a catchy title, but it produces all of the information so that another model can follow the instruction or evaluate whether an instruction is correct. And we also have human verified GPT-4 response. So we have these elements or these things that we can then use to evaluate multimodal chatbots, and we will see soon how we can do it. Okay, so far, are there any questions? Okay, cool. Now, to collect the data, I won't provide all details, but generally, we annotated everything. Everything is done with human annotations. For example, I will only give this example because this is a cool one. We show the annotators some kind of a task family, like contextual knowledge of events, like the one we saw with Lance Armstrong. And we show them a full example, like why is he waving, what happened in this event, and this is Martin Luther King waving to acknowledge a great crowd of protesters who granted him to speak. And now we tell the annotators to create a new challenging instruction inspired by the C task for that family. And they come up with this instruction. Why is this guy raising his hand? And this is actually Donald Trump in the oath ceremony somewhere in 2018, I think. Okay, and later we also collect the instruction condition caption, and we also evaluate whether the responses are correct or not. So this is how we collect all of the ingredients for our dataset. Okay, let me skip on that, not critical. Okay, this is an example of the instruction condition caption. Again, if we take a blip2 caption, that is a caption that is not conditioned on the image, we will get a sign on a brick wall. The regular captions ignores, and it is not conditioned on the instruction. And the instruction condition caption needs to be relevant to the question. In this case, the question relates to the whether a disabled wheelchair-bound individual find it easy to go into this store. So the caption must indicate these ramps that are could allow a wheelchair to go up the store. Okay, so this is like a comparison to other data sets and other works. So yeah, we have diverse tasks. We have wish list instructions where we thought what could be, what is our wish list from multimodal agents. We have 70 tested skills, 70 such categories like contextual knowledge of events, or like the all of the categories we saw in the first slide. We also repurpose existing data sets. We take existing data sets and transform them into instruction following, like we add instructions and make it in a zero-shot manner. So we do it to reflect the dynamic demands of modern chatbots. Okay, after we have um, the data set, we can now see how models deal with this data set. So we take many state-of-the-art models, multimodal chatbots that come up in the last year, and we run them, and we tell humans to say which model prediction is better, model A or model B. So here we give them only the prompt and the image without the caption or anything like that. Just normal human evaluation between models, and we ask them which is better. So this is how we build human guided rankings, human leaderboard. Now comes the more interesting part. So with the human leaderboard, we see that Lava is the best. Now actually it is Lava 1.5 is the best. Now comes the interesting part. We have human rating, but let's now use the instruction condition caption and develop an automatic judge, automatic rater, like the one before we did it with humans. Now let's make a model that is doing the same. So we have a model, GPT-4, that gets two model predictions, like the one we had with the humans here. So we have two model predictions, and the judge says which model is better. So in this case, the better model is instruct blip. And now we have automatic leaderboard. We had a human leaderboard, and now we have automatic leaderboard, and we can see, and this leaderboard is robust, and we now have the leaderboard that is online, and we accept model predictions, and we can update and see which models are the best. So this is the leaderboard, and we also have like single image, and we also have instances with multiple images. I didn't get into it. Now, how good is our automatic judge? So we actually tested it. So we took several metrics. This metric, the green metric, is actually our judge. We call it GPT-4 no rest, because notably we don't use the ground truth responses. We only use the instruction condition caption. If we can see in this figure, the input to the judge is that just the two model predictions and the instruction condition caption. The judge does not see the image, and the judge does not see the ground truth responses, like the ground truth responses. It does receive the instruction. So we check many metrics, including traditional metrics like Blue and Cedar and many more, and we see that like when we have human agreement of a high human agreement, we see a very high agreement of the models compared to the human rating. So we see 92% agreement between the auto rater and the human rater, bottom line. So yeah, this shows that our automatic metric is effective and highly correlates with human rating, and like justifies our use of this auto rater.
Can I ask a question? So like when you were showing us the image and asking like, okay, what is unusual? Like I personally didn't know what is unusual. Like, did you guys have the situation that humans didn't know what is unusual about the image?
Like okay, like in this one, okay, this one, this is like a caveman holding like a money bill.
Yeah, this is this kind of obvious.
Yeah. But okay, we when we show the responses to the humans, we told them just model A or model B. Like in the future, we can also had like both predictions are bad or both predictions are good, or like, but we did it, but we wanted to keep it simple. So yeah, it could be that some humans didn't know the answer for some questions, and even if you don't know the answer, you can like guess and have an intuition which model is performing better, because you see two models. One can be very like bad, you can see short answer and not like helpful, and one can be more effective. And we also have 5 humans rating every instance, and we also publish this data. So together, it is like usually the instances are easier to solve, and we see high agreement between the raters as well.
Understood. Jason is asking, what does the x-axis mean in the agreement graph? Can you please elaborate?
Yes, let's see. Which one?
X-axis?
Yeah, okay, yeah. So we had 5 raters for each instance. So these are the cases where 3 out of 5 of the raters agreed. So this means that like we don't have a very good agreement between the raters. And these are the cases where we have full agreement between the raters. So actually, yeah, this is a good question. Thank you for asking, because I didn't explain why the graph looks like that. So the orange line is the upper bound. The upper bound is 100% when the humans agree, and it is lower when we have lower human agreement. So this is why the diagonal shape of the line. So this is the upper bound. You can't have a model performing better than the orange line, and it drops because of the agreement between the raters. Yeah. Okay, yeah, so this was VisilBench, and you're welcome to ask if you have more questions. And actually, like, if we have time, I can start showing in more quickly the second work about the weird images. Have you tried the GPT-4 vision model? No, so we didn't try the new GPT-4 model. We did add many models recently, including Lava 1.5. Usually, like, I am more inclined on using public models and not GPT, because like GPT is a product, it is not like open source and so on, and it can change in every time. And like, I'm okay with using it as a judge, but yeah, but we could add GPT. Like, it is very legitimate and will be good to add, but it just more models are coming up all the time, so we are limited eventually. Okay, are there more questions? Okay, I can start like in five minutes talk about this work. Does it work, Sophia?
Sure. Take your time.
Okay. Okay, cool. So what makes these images weird? So I told you we will get back to it. So, okay. What about this image? What makes this image weird?
That he has iPhone?
Yeah, and who is it?
Einstein, right?
Yeah. Okay. Yeah, and he died before the inventions of smartphones, right?
Mm-hmm.
Okay, this is a more challenging one. What makes this image weird?
It's a candlelight without any oxygen.
Great.
Yeah.
Yes, candlelight without oxygen. And this one?
Howling at the sun.
Great. Yeah, you got it. Okay. Now these exist in the wild as well. There is an image of like Messi and Ronaldo playing chess in the latest World Cup, and these kind of images always intrigue us and engage us. And this is like really testing whether you have common sense, I think. And yeah, GPT-4 also had similar image, not in the same style of whoops, but we published whoops in the same day of GPT-4, so we did like they it was a parallel in the same time. So okay, so whoops is a benchmark of synthetic and compositional images, where we hire designers that use text-to-image models like Midjourney to create such common sense defined images. And how to create a weird image? We told them to think about an image that depicts two elements, X and Y, that are likely to co-occur. For example, AGI and ASI, what is
ASI, I don't know what it stands for.
Yeah, okay, never mind. So we told them, think about an image that depicts two elements, like Slash playing a guitar. Okay, the guitarist / playing a guitar, and now replace Y with a different element, Y prime, that is unlikely to exist in reality. So instead of a guitar, let's have / playing a saxophone. And we the designers generate this image with Midjourney, and now we have a common sense defined images. And they also add the reason, like the explanation. / is known for playing the guitar, not the saxophone. Cool. And so we generated many, like 500 images from different reasons. So we have atypical behavior. This is a cat jumping to a tennis ball like a dog. We have object shape. So this is a glove with 6 fingers. Age mismatch, safety, cultural knowledge. So these are little girls crying on Disneyland, and so on.
Little girls can cry in Disneyland.
Yeah.
Yeah,
Mothers tell me that this is very actually. Yeah, mothers tell me that this is very not unusual.
Exactly.
So, and after we have the images, we now collect annotations. So we now create tasks for multimodal models. So we have the task of explanation generation. So we have the image and now we have the explanation. So the model is expected to say that panda live in the China bamboo forest, subsist almost entirely on bamboo, and do not hunt salmon fish like grizzly bears. And we also add 3 established tasks: captioning, cross-model matching, and VQA. Like, what is catching salmon in the stream? A panda, and not like a grizzly bear. And we have 2 models. One model is end-to-end, where we fine-tune just end-to-end from vision to response. And the second one is a pipeline, where we first predict a caption and then activate GPT to produce the explanation. And we do it both with the predicted caption and both with the ground truth caption that we collect from the annotator. So this is actually an Oracle model. And bottom line, these are the results. So we can see that according to human rating, the 0-shot blip 2 gets 0, so we cannot handle the task. The fine-tuned blip 2 gets 27, so it is a very low. And the pipeline model with GPT-3 gets 33%, all much lower than human rating, which is 95. By the way, I didn't mention it. VisitBench will be published in Europe, and this was published in ICCV. And with the ground truth caption, the result is 68. So again, bottom line, it is easy for humans and challenging for models. And in the paper, we also add automatic evaluation, and we also add many more models to compare. And these are some predictions from Blip 2, the fine-tuned Blip 2. So the Statue of Liberty is in New York, not Sydney. Babies are too young to read books. And the Cookie Monster eats cookies, not apples. And maybe a last thing is that we have 2 cases. We have 2 factors for the challenge. One is the weirdness, and one is the synthetic nature of the images. So we want to decouple it. So we actually took the strange images. So this is a strange image of a person skating on like a basketball parquet, and we created normal images with Midjourney. So this image is synthetic, but not strange, not unusual, and also normal image. So this is not synthetic and not unusual. And we measure the performance, and we see that the accuracy is high for both the natural and normal categories. So it says that the model does not have a problem dealing with the synthetic aspect of the images, but it is low for the weird category. So the model is actually struggling with the weird aspect of the images. So that's it. You're welcome to check out both websites, both of VisitBench and Whoops. And we have an explorer that shows all of the images. And so this is Whoops.
Thanks.
So
Thanks.
takeaways: multimodal is important, and data sets are important, and so on.
I actually had a question, like maybe I missed it in your talk. How did you guys collected those data sets?
In VisitBench or Whoops?
Both.
Yeah, okay. in VisitBench, there was this slide, so everything with human collected. So this is the data collection framework. So like this one, we show them one instance of Martin Luther King and told them to come up with new instruction. And after we have new instruction, we tell them to create the instruction condition caption. And after we have both the instruction and the instruction condition caption, and we extract GPT for output, we tell them to evaluate whether the response is correct or not.
Mm-hmm.
So this is how we create the instances in VisitBench.
Mm-hmm.
And in Whoops, we hired image designers
Mm-hmm.
and told them to create the images. And after we have the images, we use Amazon Mechanical Turk to collect annotations for what is the reason that the image is weird, the image captioning, what happens in the image, cross-model matching, and visual question answering.
I'm wondering what is the reasonable amount of images you need to conduct this? Basically, how many images the designers created?
Yes, so in Whoops we have 500 images.
500 images.
Yes. Okay. Now this is actually something that we added in the paper. 500 is like the minimum, I guess, that we want, that we didn't, that we weren't rejected, because it is not a lot, I know, but it is still enough to have a significant test analysis. And the reason it is 500 is because creating weird images is super challenging. Actually, creating one image, we measured that it took around more than 25 iterations for one image, because the model refuses to create a panda bear hunting a salmonfish. It will create a panda bear with bamboo in the water, or a grizzly bear instead of a panda bear. The models are really biased to create normal things.
Yes.
So we described it in the paper, and we show the process of how many iterations are needed, and an example where the designers do several tricks, like they change the prompt, they add more things to the prompt, and they use in painting to change particular things in the image, and so on. The better the models, the easier it gets. But we did it just after Midjourney was became mainstream, so around month of January. Now it's easier, but yeah, we did it when it was harder.
How many human annotators did you guys have for this?
I usually use groups of starting with 30 and ending up with around 10. Yeah, this is technical. I can give another full talk about what is a proper way to do human annotations, but this isn't trivial to do such human annotations. It requires specific guidelines and qualification tests, because these tasks are not easy, are not trivial.
They're not. Actually, I mean, it was back in 2019. I was thinking to basically build annotation tool, and I was talking to people about the problems with annotators, and so many problems. Even when you give very direct instructions, people still don't follow them, or do very stupid mistakes. So it's painful.
The most important thing, I think, I believe, is having a test. You can give the most complex instructions that you want, start with 30 annotators, and do a qualification test. And only the ones that pass the qualification test, a challenging one, with 10 representative examples, will eventually do it. And the better you become at it, you start with 30 and you get 25 to pass.
Yeah. Actually, you can make a career as a professional annotator, probably.
Yeah,
did you select people with specific background, or just regular people with any background, but who are responsible and intelligent?
Yeah, usually when it involves writing explanations or writing captions, US is important, the native language, or maybe not native, they write much better than me, for example.
Yeah, understood. Also, I am kind of wondering, like when you were showing these images, and asking what is wrong with them, there could be some biases. Let's say if you show like image of, let's say, like some dictator, right? Like for one part of the world, that person could be a dictator, but for some like other parts of world, that person could be like, their leader, right? And like kind of, did you guys think about, like this biases in output?
Yeah, actually, yeah, we have here like that weirdness transfer between countries. This is actually like a bit of a side effect that we checked, but okay, the designers we used were from Israel, so Middle East, and the annotators are US. So it was surprising in a good way to find out that okay, like one designer that like I also didn't know all of the designers, they came from different ages, different backgrounds. We had like grandfathers that liked to play with me Journey, and like my sister created one image, for example, my little sister. So we had a very diverse backgrounds because the Midjourney things and like image generation draws many people also that are not like technical. They are not doing any bachelor's degree in computer science or anything like that. And we were surprised and happy to see that they thought of a single concept, and this concept transferred to the annotators and in the US, and they were able to understand it. Although like we didn't try it, like I guess if we tried with annotators from, I don't know, China or Japan or like a more distant culture, it may have been different.
Are you guys actually kind of considering doing that? Like take annotators from other parts and see like how they will interpret these things?
This is interesting, but like we are finished with this work for now.
Yeah, I'm wondering like, what do you think? What is the common use case can be for this type of models, like in real life, like how people can use this
In models like
level?
yeah, okay, so in VisitBench is like representative for the practical things, like I guess. Whoops, it is not it is not super real world, but I think that like all of the motivation for works about common sense, and also many works by Eugene Choi, if you're familiar with, from University of Washington, Professor Eugene Choi has numerous works about such challenges. So the motivation is that eventually we want agents that think like us and understand the world the way we understand the world. And this kind of benchmark and tests help us to analyze and evaluate whether they are in the level that we expect them to be.
Yeah.
So, and yeah, and I think that every multimodal chatbot is expected to be to perform well on Whoops and also VisiBench. Like I see them in some way they are a bit of a complementary.
Guys, do you have questions? You can unmute yourself and ask Yonatan directly.
I have a quick question about categories of weirdness that were the most challenging. I think we had a slide. Oh, yeah, there it is.
Yeah.
I was wondering if you could elaborate on maybe some of the more difficult categories.
Yeah, so we actually plotted here the amounts, the frequency and the performance of the models. So okay, like unsuitable environment was easy. Like we see both models perform well. So this is like, imagine a polar bear in the desert. So we have a polar bear in the desert. Now let's try to find one with a low performance. Okay. Art knowledge. Okay, so art knowledge, like this is art knowledge. You see this one? What is weird about this image?
Is the earring incorrect?
Yes. So this is like a girl with a pearl earring. So this should be a pearl earring and not a hoop. Yeah, so this is like for one example of low performance. Yeah, actually, I don't remember all of the categories. Okay, like incorrect use. Yeah, incorrect use is like I don't remember specific examples, but we can look on the examples here. Like safety. Safety is doing something that is like dangerous. So this is a fork in an electric uh, socket. Okay, this is incorrect use. This is one where the fine tuned was low of low performance, and the prediction were a bit better. So what is weird about this image? What do you see here?
Is it weird to use a magnifying glass on a smartphone? I'm not sure.
Yeah, yeah, exactly. Because like if you want to enlarge your smartphone, you can just pinch and zoom in, and you don't need the magnifier glass. Yeah, so these are some examples.
So are there any like governing principles as to what makes particular categories more difficult? Like, for example, is it just putting it out there, like, is it because some categories require more specific like contextual information that's not easily accessible, or are there other principles involved?
Yeah, actually, this is a good question. We tried to understand, but we didn't manage to find a clear trend on why some things are better than others. Yeah, it is a great question. Like it also can be like, for example, when okay, like this one requires a more, I think, niche understanding of some art. Like better, it is more challenging to find this in training data, I guess. And this doesn't understand some identification. It only it requires to understand. Okay, actually, it requires to understand the Disneyland. Yeah, this requires to understand counting. So yeah, we didn't manage to find a clear trend.
Thank you.
Yonatan, do you have like papers? Do you have like links to papers that you can find very quickly? If not, I will share on our Slack. But someone asked if you can share links to these papers.
Yeah, all of the papers can be also found in my website, and
Awesome.
and yeah, this is VisitBench, and it will also add VisitBench and Whoops.
Awesome, thank you. Do we have other questions?
I added the website.
Mm-hmm.
Yeah, and by the way, there is also, let's see if it opens, but we have like the a dataset viewer for Whoops when you can see all of the examples. For example, okay, like this is a pregnant woman.
This is only women who were pregnant will understand why.
Yeah.
Why it's a not good idea to eat raw sushi when you're pregnant.
Yeah.
Actually, in this case, you need like a kind of domain experts, right? Because like men unlikely would understand. Like, okay, but it's just or they can just Google it. Like, okay, why?
Yeah. Okay. We can see here the crowd explanation. So here are the 5 like guesses by annotators, and I think that at least 50% are men, and all of them got it. Like got the thing. But when you annotate a lot, you understand that okay, everything has a reason. So yeah.
Yeah, that they might, yeah.
Yeah. Okay.
I'm wondering, like, what do you think where this field is going? Like, what is next in multimodality we should expect, or what you're planning to work on next?
Interesting. Okay, good question. So okay, I think one thing that the world is going to is these kind of models receive text and image and output text. but we will see more and more image models that receive text, images, videos, or anything together, and output text, images, videos, and everything together. So think about one day you can tell the model, produce a commercial about the Buzz Robot reading group, and I don't know, add my picture and make it spin. I don't know, like think of something a bit crazy and creative, and also tell the model, and please be creative and make it engaging and funny. And the model will be required to do it. So yeah, it is advancing in the modalities. It is advancing from only textual to image and video without sound at first, and then video with sound, and maybe 3D and 4D eventually. And in the type of tasks, it starts from, like, let's say, descriptive analysis, descriptive alignment, like saying image captioning. It is just describing what happens in the image. But then we have more of reasoning to produce things of understanding what happens beyond just describing. And also we have interleaved image and text, like producing a sequence, produce a recipe, show me a recipe how to create my favorite pancake. So there are like several steps that need to be consistent. And more like non-textual outputs like videos and so on.
Maybe it's like strange question, but like, what's your estimate, if it's possible to estimate, like how far are we from this happening? Like, are we talking about several years, or we're talking about like decade, just like order of magnitude, just to get a sense, like in your opinion?
Yeah, I think so far we have been proven that whatever we say, it will be sooner than that.
Basically, it will be sooner than we expect.
Yeah.
Kevin is asking, what database type is used to store your multimodal data?
Like in general, I like working with Hugging Face data sets, but it is just for deployment. Basically, it is just a CSV. It is a CSV with text and images. So the images are all just linked to AWS S3 bucket, and that's it.
Awesome. Thanks. If you guys have questions, please fire away. Otherwise, we can wrap up our talk. I shared link to our Slack. Please join, and I will share the recording of this talk there, and also other announcements of our upcoming talks. And also on December 6th, we will have a bug out happy hour if you want to join, just to hang out with each other and talk and get to know each other. I will make a separate announcement about that. Thanks a lot, Yonatan, for your time. I know it's late night for you, so thanks. I really appreciate that you found time to join us today, and thanks everyone for joining.
Thank you very much.
Bye-bye. Have a nice evening, everyone, and day. Bye.
Thank you.